In the following video, we're going to actually solve systems of equations. Now, when you're solving a system of equation, the solution that you're looking for is actually the point of intersection. The solution itself is an x, y coordinate. So your graphs can intersect in an x, y coordinate. Now, we learned in the previous video that you can have lines that are parallel to each other. And for our classification for parallel lines, we said, hey, those are inconsistent. They do not intersect each other. And so if they don't intersect, there's no point of intersection. So for those lines, we say there's no solution. We also learned there is one called consistent dependent, which meant you actually had the same exact line. And so the same line meant they are always intersecting. And so we refer to that as infinite solution. There are infinite solutions to this. So we still look at those classifications away because there's three types of ways lines can, intersect. Using that word loosely, they can intersect at one point, they cannot intersect, or they can always intersect. And so there's three possible answers we can have when we're actually solving systems of equations by graphing. An actual x and y coordinate to show that the two lines intersect. Write down no solution if your lines are parallel, or infinite solutions if they're the same line. So let's try this on number 1. Let's actually find the solution. So I start off with 4x minus 6y equals 12. I would subtract 4x from both sides to get it into slope-intercept form. That gives me negative 6y equals negative 4x and plus 12. I would divide every number by a negative 6 to get the y by itself, and then simplify. Negative and negative is a positive, 4/6 is 2/3. So I have 2/3 x, and 12 divided by negative 6 is negative 2. So let's graph this. We have a y-intercept of negative 2, a slope of 2/3, so up 2, right 3, up 2, right 3, down 2, left 3, and down 2, left 3. And then we're going to connect these with our line. Now I'm going to color code this first, so that way we know which graph goes with which line. So the next one, 2x plus 2y equals 6, we're going to get in slope-intercept form. And I'll use green for this one. Same idea, you move your x term over by doing the opposite operation. So 2y equals negative 2x plus 6. And then divide every term by the coefficient of y, 2. So y equals, and simplify, negative 2 divided by 2 is negative 1. You don't show a coefficient of negative 1. Just write down negative x. And 6 divided by 2 is 3. So I have a y-intercept of 3, a slope of negative 1. Now I can go down 1, right 1. I could also go up 1, left 1 across the whole graph as well. Now if I were to continue this pattern of down 1, right 1, look at what happens at this point. You actually see an overlapping occur at that point on the graph. So down 1, right 1. So if I were to sketch this graph, I can see this is my point of intersection. That coordinate is my solution. So the solution here is the coordinate. Looks like 3, 0. That is where the two graphs intersect each other. Let's move on to the next one. So we see the rule is get them into slope-intercept form graph and then find the point of intersection. So let's look at number 2. I have 12x minus 9y equals 27, and I have 8x minus 6y equals 18. So again, let's get each one in slope-intercept form and graph. So you have 12x minus 9y equals 27 Move the x term over by doing the opposite operation. So since it's positive, I'm going to subtract. And you get negative 9y equals negative 12x, and it's a positive 27. And then divide every term by negative 9. And simplify. Negative and negative is a positive, and 12/9. 3 goes into 12 4 times, and 3 goes into 9 3 times. So I get 4/3 x, and 27 divided by negative 9 is a negative 3. So at negative 3 on the y, I can't go down 4, left 3, so I'm going to go, sorry, down 4, right 3, down 4, left 3. So I'm going to go up 1, 2, 3, 4 to the right 3. And I'm going to go up 1, 2, 3, 4 to the right 3, since it's a positive slope. And then connect with your line. And again, I can color code this to make sure we can distinguish between our two lines. And then I'm going to do the next equation, 8x minus 6y equals 18. Move the x term over, so I'm going to subtract 8x. I get negative 6y equals negative 8x, and it's a positive 18. And I'm going to get rid of my coefficient of negative 6 by dividing every term by negative 6. And then simplify. Negative 8x, so you have negative 8 over negative 6, so negative is a positive, and that simplifies into 4/3. So I have 4/3 x. 18 divided by negative 6 is a negative 3. So you have a y-intercept of negative 3 and a slope of 4/3. So you go up 4 to the right 3, up 4 to the right 3. And I look at this, I see they are the same exact line. I can also see they are the same line because I have the same slope-intercept form equation. They are the same equation. They are the same line. That means they always intersect each other. So infinite solutions. And so we see an example of what an infinite solutions graph looks like. Let's try the last one. You have 4x plus 6y equals 18, and 6x plus 9y equals 18. Slope-intercept form. So if I have 4x plus 6y equals 18, I am going to move the 4x over by doing subtraction, since it's a positive. And you get 6y equals negative 4x plus 18. And divide by your coefficient. So divide every term by 6 to cancel it out. And then you simplify. Negative 4/6 is actually negative 2/3. So you have negative 2/3 x. 18 divided by 6 is 3. So you have a y-intercept of 3, a slope of negative 2/3, so down 2, right 3, down 2, right 3, or up 2, left 3. And we can't go any further. So then we're going to sketch our line. So let's make this line blue. And then we're going to do the next one. 6x plus 9y equals 18. Get it in slope-intercept form. So I'm going to subtract 6x and get 9y equals negative 6x plus 18. And then divide by your coefficient of 9 with every term. That gets the y by itself. Negative 6/9 is actually negative 2/3. And 18 divided by 9 is a positive 2. So I have a y-intercept of 2 and a slope of 2/3. So down 2, right 3, down 2, right 3, up 2, left 3. And go up 2, left 3. And then sketch your line. So same idea, if I were to color code this one for us, we see our lines do not intersect each other. I can even look at the equations themselves and see I have a slope of negative 2/3. I have a slope of negative 2/3. So they are the same slope, which means They're parallel. I can also tell they're parallel because they are same slope and different y-intercepts. And so parallel lines never intersect. So there's never going to be a point of intersection. So we say there is no solution. So let's examine this further and try and apply some logic with how I can see at least what type of solution is going to occur based off of what my two slope-intercept forms are. Now, if we go through, we saw there were three types of solutions. There's a one solution where we actually had an xy coordinate where the two lines intersect. We had the second example, which was infinite solutions. And we had the third example, which was no solutions. And so we have to go through and we can figure out what occurred in each case. So in the no solution case, that last example we saw that the lines were parallel to each other. And so we have to ask ourselves, what are the forms of our slope-intercept when it comes to parallel lines? What are the characteristics? Well, we say parallel means they have the same slope. And we learned that. We've learned that when we were actually writing equation of lines. Parallel means same slope, good. However, don't infinite solution examples, didn't our infinite solution examples, they were the same line? So if you have the same line, don't you have the same slope as well? So something else has to distinguish between our parallel, our no solution, and our infinite solution. So let's take a look at this. So if we look at our infinite solutions, they do have the same slope. But what I see as well is the same equation. They also have the same y-intercept of -3. And so if I look at the no solution example, they do have the same slope of -2/3, but this time I have different y-intercepts. And so no solution is going to occur when they're parallel, which means they have the same slope, but they have different y-intercepts. Same lines are going to have the same slope and the same y-intercept. They're going to be exactly the same equation. So what did one solution look like for us? And so one solution, 2/3 is my slope, -1 is my slope. One solution, in order for an intersection to occur, your slopes just have to be different. That's it. And so one solution, you're going to have one point of intersection. You're going to have different slopes. And that's going to give you one point of intersection for your solution. And so we can actually look at our equations themselves and look at their characteristics on how do I know what my answer is going to look like for a system of equations. So when I get to my slope-intercept form for this, I can see, hey, I have different slopes. That tells me I should get a point of intersection. Or I can go down through it, example 2. I see, hey, I have the same slope and the same y-intercept. Well, that's the same line. I got to have the infinite solutions for this one. And for the next one, no solution. I have the same slope and different y-intercepts. There's no way those two are going to intersect. So try and find a connection between your slope-intercept forms and what the graphs look like to kind of go through the thought process of checking your work and checking what the solutions should mean for graphing. I mean, overall, the process is the same. Get them in slope-intercept form, graph, and look for your point or points of intersection. And your solution is that coordinate.